Alrighty. Let's roll. There we go. Okay, I'm beginning to stream, and we're seeing the stream come up, and I got to scamper around and do some of the things associated with my stream before we can get going doing coding or whatever else it is that we're going to do. But all the same, not so bad. It's only 1 minute past 11. I do tend to try to stream or whatever at 11. Let's fire up that chat window in case anybody comes by to say hello, and set it to live chat so we can see anything anybody has to say if they do come by and say hello. And yeah. So hey, this is going to be a probably more of a chill sort of stream. Like I mentioned, I've got a bunch of stuff going on, like my hot water heater on the outs. And I'm going to be trying to follow up the low pass filter that I did. I've had some thoughts on the low pass filter also. It occurs to me that I might want to be incorporating something that's part of the Z-plane filters in the EMU sampler that I don't have going on, and it shows that I don't have this going on at the moment. The filter that I put out is indeed a biquad filter, but the thing is that the one in the sampler, if I'm given to understand how the Z-plane thing works, they do it all by generating a bunch of parameters for how the biquad works and kind of crossfading between them. And that's something I'm not doing. Like right now, the stuff that I'm doing is generating the biquad filter, but it's not crossfading between the coefficients. Hey, Master Spoogie. And for that reason, when you move the slider around, there's a bit of a ratchety noise, and I don't think that's consistent with what the EMU filters do. I think the whole point of the EMU filters was that they were doing this, and the idea was to be able to crossfade between different kinds of biquad. And what I'd be using it for, here, let's jump right in to coding land. So might as well do that. So what I'm using the biquad filter for, don't mind me pumping the volume on these speakers up a little bit so that you can hear them when I have something to hear. Let's go and have a look at that. As you can see, here's our controls, and the very last minute, if you were watching this being coded in previous weeks, I added another thing, which I think is a smart idea. These are the ones that crossfade between each other. This is A, B, C, and D are the ones where I can use like a dry-wet control to go between dry and A, or between A and partly B, or entirely B and partly C, and so on and so forth. You have a linear way of scaling up the number of stages, which is not normally how that works. You don't normally get to have like 2.5 poles of filter, but doing it this way, it acts like it's 2.5 poles of filter, and that's why I'm doing it. But that meant that the dry-wet was always just, the only way you could get to dry was going all the way down to 1 pole and less. And on thinking about it, I thought that people wouldn't like that. So what I did was I added yet another biquad filter for a total of 5. And this one doesn't have a letter by it. We can see it again in the code here. Here's the code where I'm going between dry and 4 stages like this. And this is what causes that to do it. But then I'm adding another stage, which is an always on first stage. So now the control that was originally, the nuke control, which was originally dry wet, is going between 1 and 5 stages rather than 0 and 4. So this always runs. And then I'm saving the dry sample as before and using it on the end as just a completely traditional dry wet control. And as you can see, I've tacked the initialization in here. Same deal. Now, the thing I'm thinking about today, on the one hand, I would like to do a Highpass, or at least start getting that together and seeing what we hear out of it. I've been, oh, well, look, well, hang around. There's lots more of these on my channel. So the way I see it, I'm not actually very clever, but my right brain is on point. So I get real stumped and confused by a lot of this stuff, and the way that I code it is not as a capital P programmer would be figuring out some way of having all this be about 3 lines of code and very abstracted. And my stuff is written a little more like assembly language. But what I do to sort of justify, my relatively small but still fairly significant pay grade as Airwindows is think of novel things that are worth doing. And that is in some ways more important than being able to think your way through all the abstractions and stuff. In fact, I guard against getting too hung up on abstractions. For instance, you'll see that the way these are implemented, it's 4 different biquad filters. You could implement that. Let's go up here where we're looking at this sort of thing again. You could implement that as 4 filters like this. Something like that. And it would be a multiple array, an array of arrays. And I chose not to do that because I just have a letter in the name. And the way that I'm making these arrays all be the same. Now, what's jumping out for me today, as far as the Z-plane filters, and I should probably mention right up front, because I've been embracing this more and more as I continue onwards. I face some challenges at being a YouTuber when doing this type of work. And it also affects the music that I do. And it's going to be a continuing process of figuring out how I can maximize on that. Because when I was reading a book that I got recently, Drawing on the Right Side of the Brain, I started making all these connections with how that works. And it was real interesting for me. That book tries to teach you how to be a skilled artist on the grounds that the stuff that you're drawing is not easily expressible by words. Like the shape of a line on the paper as you draw it. Here, I'll go back to just for now. The shape of the line on the paper as you draw it is not easily expressible by words. You don't really go like, okay, in order to do this nose from this angle, it needs to be 30 degrees this, and then exactly 50% of that. Instead, it's this abstract shape that is hard to describe. If you were to really absolutely nail like the shape of a nose or something, it's almost certainly going to be really tough to describe in words. And although this is not necessarily given, I think in many cases, people's brains and their left and right hemispheres and so on do tend to distribute themselves towards different kinds of tasks. And it is said, if I'm remembering it correctly anyhow, that the left side of the brain is strongly verbal and generalizes and categorizes. It's like the scientist or the nerdly programmer side of the brain, where it figures all this stuff out and expects things to fall into categories and make sense. And drawing pictures, you have to force yourself to go out of that side of the brain, because otherwise the left side of the brain will go, oh, I am drawing a nose. A nose is a kind of triangular shape. It's sort of pyramidal or whatever. So I will make this line and this line at roughly this angle, and that will be a nose. And a nose is like thus and so regardless of where the actual image is, it's like, I'm going to put the symbol for nose here. And you get enough of that stuff, like you're drawing eyes, for instance, and you're trying to draw eyes for some kind of person or character or something like that. And you find that left side taking over and going, an eye is about this big, and it's this open, and these eyes are the same size because they are eyes that match. Mind you, if you've got the head tilted, they're going to be very different sizes. Maybe they will be obscured to the point where you can barely see one eye at all. And at the first glance, it's like, well, this looks normal. But if you really think about it, you're only seeing part of one of the eyes. And yet, if you draw it, you're like, well, an eye looks like this. And so you draw an eye symbol in both places, and then you make them roughly the same size. You're like, well, they're the right size, aren't they? And it completely destroys the ability to do good representation, because the left side of the brain is taking over in an area where it doesn't belong. What I have found in doing the coding, which I will switch back to momentarily, is that I struggle very hard with that left brain stuff. Like, some of the most simple things that you should be able to figure out are very hard for me. But at the same time, when I start clicking and thinking of stuff, the right side of the brain takes over. And what happens to me then is I'm throwing ideas together very rapidly, because I'm chasing some kind of idea of, say, seeing as I have to put it into words now, I might be going, when I roll this filter off, and it's supposed to be kind of a distorted filter, it should have a particular sort of gnarly growl, but it shouldn't be clipped sounding. So if I have more pulls of the filter after it clips, maybe that'll give me more of the sort of flavor of growl that I want out of this. And I'll be maybe imagining a new kind of tone out of it. And you saw this happen with Xlowpass. Like, you can download Xlowpass now and play with it. And it came out of that sort of thing. It came out of going, if at each stage of this distorting filter, I had things distort just a little bit more while also filtering more and more, then maybe it will have a useful characteristic, in which case, how much of this increasing volume should happen. And then I would discover, oh, that made the low frequencies come out more, which is something people are already noticing about Xlowpass, and that's going to be kind of part of the filter. And my brain will be very much caught up in operating on that right side, because it is working very hard trying to figure out what flavor of this peculiar quality of the distortion in the filter, what maximizes this flavor in a way that's going to be useful for, like, use on this drum sound or something. And actually, I can probably, here, let me fire up a file, and I can be talking while also playing audio and demonstrating. Like, the whole trick with that stuff is I can play some audio. And we can have that going on, and when you roll the filter down, can get this distorted quality going on. And if you're not distorting it that hard, or here, let's back it off just a bit. People were looking for this peculiar distorted quality. And as you get more poles of filtering, you start getting more of that quality happening, to the point where we can really magnify it. And that's because the filter is steepening, but we're also adding a little bit more gain each time. And we can also make it go completely ridiculous. Now, one of the things I mentioned just came up. If you listen to the sound this is making, there's a little crackliness, and I know what that crackliness is. It's something I have not implemented in this filter, and I might just leave this one, like X might be left the way this is. It can be the most simple version of these. But what's happening here is this is zipper noise. This is the control being manipulated. And there's this faint crackle because there are low frequency waves going on. You can't hear it as easily up here because we're kind of swamping it. But down here you can hear the slight crackling. And the reason it's doing that is because, let's see, we're calculating this stuff, which is part of the insides of the filter. Every time we call this, this is the process function, and it has this coming in frames to process, and in sample frames becomes that. And then we're making these, we're being shown a buffer. This gives us stuff that we can use. We get down here and it says when in sample frames minus minus is larger than 0, which is part of sort of the template code for how the audio unit works. And then at the very end of this, we go source P plus equals in num channels. That's something from the audio unit. This is doing one channel of however many channels are coming into the plugin. The audio unit can do mono, or it can do stereo, or it could do quadraphonic or 5.1 if you asked it to. That's one of the neat things about audio units. But this is basically going, take one step to the next sample in the list of samples that we're given. And it's going to do that as many times as n sample frames is larger than 0. And every time we ask this question, this is asking this question while also changing the number. It's the same thing as and it's effectively this little arrangement here, or specifically this part in here is that above, because the second line here, that's what n sample frames minus minus does, is it asks this logic question, and then while passing through and calculating that, it's also going to subtract 1 from it. And this inside the parenthesis, this is a logic question. It says greater than 0, and so it's going to answer true or false. And while true, it will do the stuff in here. When it says false, it will not. Also, another detail there is you can phrase this either as n sample frames minus minus or as minus minus n sample frames. And if you did the former, then it would subtract 1 and then use it in the logic thing. If you have it after, as this does, it compares it in the logic thing and then subtracts 1 after it's done the comparison. And these are things you learn if you're dealing with programming in C. But bottom line is, this is happening for every sample. This is happening once per sample buffer. And n sample frames is the size of the buffer, and the buffer is called in frames to process. And this is as many channels are in the audio. Like, is it stereo, is it mono, or whatever. Now, it might be worth me doing this, going into low pass and sort of beginning that, because I can start low pass by just copying all of this over and then modifying it from there. I am of a mind to keep X as the simpler form, but by the time I get to Z low pass, I feel I'm going to have to include this particular thing. And I'll tell you what it is. See how we've got all this stuff up here? We end up with, let's just scooch down here. Say we've got this here, and we're doing these calculations, and these are some of the parameters that we use in the biquad. Like, outsample is biquad 2 times input sample. Though this is all stacked together, but that works in math. Like, the way that I don't remember off the top of my head what the precedence of these operators is. And that means if we're doing this, it's going to mean like the same as this for all of those little factors. It's going to combine all of that stuff and only then add the results together. And that's because of operator precedence, and I don't have operator precedence memorized, so I'm not sure exactly which is which. I know that this mystical incantation works. And you could put parentheses and everything just to make it explicit, which often I do. I often put stuff in even when precedence doesn't absolutely require it, because I would like to think of it in a certain way and have it drawn explicitly on the page so I can see what it's doing. So we start our biquad filter by taking this factor and multiplying it by input sample. Now, that's being recalculated each time. We start with this, which ends up being like, this is the frequency that we want. It's going to be somewhere between, it's larger than 0 and it's going to be less than 0.5. As a rule, that's how that works out. And I've got it as always larger than 0.001. Closer to 0 you get, the more low frequency it's going to be. And you've got stuff like, I think actually in this I'm not even using biquad A1 because it is this number. I'm using straight Butterworth resonance. I'm using 0.7071, which is the Butterworth filter slope, because that's what's consistent with the low-pass filters in the EMU that I'm concerned with. So we're leaving that stuff out. So we have an entry into this array, which I'm not even using. But then we start using that stuff, like K is a tangent of pi times this number. So that's going to change. If I was doing stuff like I was doing while I was demonstrating things, and I could go back and fire that up again. What's happening when I do this? K is changing because it's going from a high frequency to a low frequency. But it's not changing on absolutely every sample. And biquad filters sometimes don't like you to modulate stuff in them like that. But the ratchety noise that we're hearing, that's because I'm moving this around. This around. And that's changing this number. And then this number is changing all of these because it's going into K here. And K is producing this number, which is a bunch of 1 divided by 1 plus K divided by the filter slope plus K times K. So it's like that's, and it's already a tangent of pi times whatever that was. It gets really flaky. At least the maths of it are not something that I keep in the top of my head at all times. And then we take that and we multiply it by norm, and that's biquad A2. That's what we started out multiplying our input samples by. And all this other stuff, like for this particular filter type, biquad 3 happens to be 2 times biquad A2, which is this again. We could keep unfolding these so that it would say stuff like biquad A3 is like that, and that would work too. Biquad A4 is the same thing there again. But yeah, the thing about it is the way that, supposing we didn't have poles of the filter. Instead, we were doing it like we had 2 different things that we could do, and we could go and go, we're going to go from A to B. We're going to go from the beginning of the sample buffer to the end of the sample buffer, but we're going to morph this filter. So does that mean we're going to go through all this calculation over and over again? No, not necessarily. What we can do is go, this biquad filter is like this, and so we're going to generate these numbers and assign them to like 2, 3, 4, 5, 6, like that. And then the other side of the morph is going to be a different biquad filter, and we will generate these numbers again like this. And your basic biquad filter is very flexible. It's just a way of feeding back different parameters of either what's called an IIR filter, which means how much of the filter of the sample coming in gets turned into the output sample. How much do we include of the previous sample? How much do we include of the sample 2 samples before it? And then there's also another factor, which is that output sample. How much do we include of the previous output sample? That being another way to manipulate the sound. How much do we include of the previous output sample before it? So what the biquad filter does is it generates all these interesting filter slopes based on just calculating this stuff out. And as you can see, it's kind of a fancy algorithm, one that I don't really keep in my head. I use it like a magic incantation, but that's basically how it works. It's manipulating, just think of it as echoes. you could in fact use it as echoes. You could build a biquad filter where instead of being the previous sample and the sample before it, you could have it be like a second before and then 2 seconds before, or after rather. And that's exactly what I'm talking about, Weird Constructor. You're way ahead of me. And so if we're in the sample buffer, we end up doing actually, I have a dry wet down in the bottom of this, so I'll just steal that because it's the same kind of thing. It's like we're doing a little wet dry factor here, but instead of being a dry wet calculation, the one thing is this, other thing is that. And I just confused things a little bit here, but tell you what. Say you got 1,024 samples. So what you do is you make this end thing go from 0 to 1. And if you're at the end of your buffer, say in sample frames, because that's what we're going to be using, and then we're starting at that. In fact, we have that as an available number. So we're starting to look at stuff that is functioning code. And oh goodness, yes, the interpolating between two biquad coefficients is not safe because biquads break out and blow up very easily. One of the ways that they blow up easily is if you don't have enough resolution for their calculations. Another way that they can blow up easily is if you're trying to make them go to frequencies that they don't like. For instance, if I set this up so that the lowest frequency that I can hit isn't this one, but is something that's almost 0, and you move the filter around, if it's at a low enough rate, it will always like blow up the output and make an enormous thump. When you're moving lower, or possibly also higher, close to the extreme that the filter can go to. I believe it's also the same at the high frequency mark as well, that if you are up at 22.050K at CD sampling rate, and you move it in the direction of that, you can also get nasty crackles, and it makes really loud noises when it does this, so you sort of have to clip it. But that is very much the problem that you get. The thing is that the EMU folks did not care so much about problems. They just kind of did stuff, and I respect that because that's how I like programming things, is see whether things will work or not. And that's why we're using a biquad filter that is not particularly arranged to behave well, and we're just making it possible to move the control around anyway. That's what's in the current version of Highpass. So the trick with doing this, and we don't need to look at that anymore, is coming up with a way of making these calculations. And essentially what we're going to do is, see how we got biquad A 0, that's our frequency. We're going to do all of this. We're going to calculate all of this stuff out, and then we're going to say old after we've already calculated the frequency for all of this stuff. And the beginning of sample buffer that we make is going to be off of old frequency, and the new information coming in is going to go to what will be new frequency. So we'll do two separate biquad calculations for each pole of the filter, except there's yet another detail, which is this biquad implementation I did just to be able to plunk a filter down and only have one array to apply. That's not necessary. I could give all of these more descriptive names, like previous immediate sample or whatever, and they don't have to be numbered, they don't have to be in any particular order. It could be Fred, Arthur, John, and Howard for all the difference it would make. And every pole that I'm using is actually the same coefficients. See, one of the reasons we're not doing this for every sample and like interpolating the frequency or whatever is because this is a bunch of math that includes, tangent calculation. A lot of this is not that complicated math, but there's still a bunch of mathematical operations going on every step of the way here. And then we have to do this stuff for every sample. But we don't necessarily want to take this and paste it right into the middle of the every sample calculation. And even if you did, it wouldn't necessarily behave very well. So what we're going to do when we move towards the Y and Z forms of these filters is start implementing this stuff. Start implementing what we've got there. In fact, we'll copy it to the desktop and then get rid of it. But it's going to be stuff like this, where we are calculating the stuff inside the loop for everything that's relevant. Like everything that's biquad 2 is instead going to be a calculation like this. And at the beginning of the buffer loop here, we're going to come up with a number that is n sample frames divided by n frames to process, and that's going to give us something that is going to go between 0 and 1. Although it does matter which direction we're going, because the thing is, n sample frames minus minus means it starts at the full number and then goes down to 0. So that means that our end number is going to go from 1 down to 0 at the end of the buffer. So you might actually be wanting to call that start and manage it kind of like this. I'll copy that over to my desktop again because this is a fair point. We'll do the invert of it, where beginning of the sample buffer, the amount that we want is going to be from there. And the thing at the end of the sample buffer is the information oh dear. I think I should comment this stuff out so that it doesn't do weird things to... And once we've calculated that stuff, then we have the old frequency equals frequency. Well, calculating that stuff out, and then when we get into the buffer, we start at the top of the algorithm right here where it says things like input sample equals asterisk source P. And this here is denormalization code. And this here is where we get our dry sample again. And we start up here, and we're also going to throw in this start equals and sample frames divided by in frames to process, because we have both of those things available. And then we will have a number that goes from 1 down to 0 that we'll call start, and it's how close we are to the start of the buffer. Hey, good. Hey, I hope I pronounced your name right. And thank you for the slidey thing. It's very cool. I'm starting to get into that zone where I don't have my words. This is partly because I'm trying to decide whether I'm going to do a generic X high pass or whether it's time to start moving towards doing the Y low pass and moving in the direction of this stuff. Because here's the deal. Interpolating between two biquad coefficients is absolutely what I'm going to be doing by the time I get to Z low pass. Because the Z-plane filters did their Morphe stuff with that technique. And that should also be how I can make the crackling noises go away when you move stuff around in the interface. Like if you have a heavy enough bass frequency, you'll get those crackling noises even on a simple gain change. That's literally what we call zipper noise in a DAW. And my understanding is that you don't necessarily have that problem with the Z-plane filters, although I could be mistaken. I haven't had time to actually experiment with the one that I've got. So that's another reason why we're not diving into the Z mode just yet, is I'm not ready because I haven't had the opportunity to work with the sampler I bought. That's just how it goes. And I don't have time now because I got some coding on stream to do. So let's see where we're at. So I think the next thing to do here, and I do feel like I would like to do the high pass thing. I have a little, what am I doing? Open is not what I wanted to do. And I might want to be able to fit that notch filter thing in again, because I have no idea what you'd get out of a distorted notch filter. I could. Oh, fair enough. Okay. Now I'm filled with the urge to do stupid American pronunciations. Namaste from Japan. I know that's wrong. I assume that's wrong. I have no idea what I'm talking about. Keep me away from words. Anyways, high pass. I should try to do X high pass because I've started asking people what they needed out of the EMU high pass. I'm in contact with some of the DNB folks who wanted this so badly. And for that reason, I'm very curious what they wanted out of it. Yeah, you will certainly get zipper noise from X low pass. Oh, well, even with paid stuff, that would mean that they're doing the same thing, that they're not addressing this. And the question I have in mind is, would you get zipper noise on respaces if you were using an EMU sampler, like the hardware unit? I don't know, and I haven't had opportunity to find out, whether they've got that covered in their implementation. I know that it is a very primitive, simple implementation because this is sort of the dawn of time, and they didn't have a lot of processing to throw at the problem. But it's all in how you handle it. And I've just done some outlines in how this stuff works. I'm also going to quickly start going through here and making some of this go. We'll add the additional thing. We'll copy over the basic controls, but leave the other ones there in case I need to fool with additional controls. We'll copy over the default parameters because we arrived at those. So now we have a lot of extra knobs available, and we've got all the biquad filters we need. And we'll go over to the CPP file and start fooling with that. Well, I hope to have the opportunity to answer that. That's one of the things I need to do. Like when I dive into this kind of stuff, there are things I have to do in order to solve it. And one of those things is going to be I have to actually measure and test out that EMU and find out what its zipper noise behavior is like and so on. Because it's just as capable of having that, assuming it operates by buffers. It doesn't necessarily operate by buffers. It could be doing stuff on a sample by sample basis for all I know. And that'd make it a very different behavior. But I don't know yet because I haven't tried it. One of the challenges with this kind of stuff is, even though my left brain is not very useful as far as resolving this kind of stuff, right brain stuff still counts though. You can mentally exhaust yourself by just dropping into the zone really hard and spending hours on end like, what can I code here, how to type, doing all of this different stuff, and keeping track of it in your head with that right brain, not being able to verbalize any of it. And when you finish, you've got a cool sounding thing. You've successfully made the thing work, and yet you're almost incapable of verbalizing what it is that you did, and then you're still exhausted afterwards. And that's what I get into sometimes. In fact, sometimes that's what I get into with music making. Like, one of the things I'm learning is I want to adapt my music making and jamming into something that works for me. And I find that every time I try to boil stuff down to rigorous song formats and hit songs and things that fit into a 3-minute whatever or fit into a genre or all of that kind of stuff, I wind up hating it and I quit. And I don't want to quit music. Normally it's something that I enjoy, and I've figured out that the reason for that is because when I'm trying to boil it down to something that other people will accept, when I'm doing the studio musician thing of interpreting and understanding what I'm doing and sculpting it, tailoring it to a particular direction, I don't enjoy that stuff. I'm not a good studio musician. I'm almost incapable of doing what would work for a thing or what would work for a situation. But what I enjoy is diving into the right brain side of things and starting to jam and making a sound kind of evolve and happen and pursuing it where it might go, especially if it's able to like algorithmically throw its own variations in, which I can adapt to. It's the jam session, but with the modular synthesizer. And that's the stuff that I appreciate. So I'm diving more into doing that. And that is more rewarding than trying to serve both masters, as it were. But it can also be tiring too. So these are all things to consider. I do know what some of the, like, when you, are you sure you mean Altec or do you mean Pultec? Because there's certain things about that I know real well. In fact, I might look into that for some of the DIY streams. Like I'm not sure whether Langevin, I don't know whether Altec is the same thing as Pultec. Passive filters generally means Pultec. But if you've got a switched thing, those filters are capacitance and inductance networks. Those are sets of very simple electrical components. I don't know what the Altec 9069B is. I could look it up, I suppose. when they are simple passive filters, those are some of the best sounding filters that you can get. They are not phase linear, and they are the same kind of thing that you can get. You know an 808 kick drum? You know that kind of stuff? Or indeed the cowbell sound off of those old Roland drum boxes, like doom, doom. Those are essentially the same type of filter. Passive inductor capacitor filters ring. If you have them in a feedback network where, I'm trying to remember, the twin T filter is a way of doing this. In fact, I think that's the kick drum technology. That is a filter design that rings. The amount of feedback at only that frequency is what causes the ringing in the filter. It will continue to sustain and make a sine wave if you keep it up. You vary the inductance or the capacitance, both of which generally have to be switched rather than being modulatable by voltages coming in. Then that's a very pure sine wave coming out of the result of that. If the regeneration is not like 100%, it will be a sort of bong or ding noise, sustaining and then dying away. It will die away with a neat exponential envelope, like an acoustical sound dying away in free air, or a physical thing that's vibrating and then dying away to silence. And if you're talking about having artifacts when moving from one frequency to the other of a stepped high-pass filter with a passive inductor capacitor network, you're probably talking about just pinging the various filter parameters. You're talking about taking those inductor capacitor networks and pinging them as they go through. So essentially what you're talking about is, it would be nice to get a stepped high-pass filter that you could pan from one frequency to the other and cause a little spectrum of cowbell or kick drum type bungs as you continue going through. They're probably not very sustained, but that's what you would be hearing. And if you're liking them, it's probably because they're very pure sine wave. They're very pure sine wave artifacts, rather than, I would call them the opposite of crazy. They're very melodic artifacts. You're basically talking about having a filter, except as you change the knob, the switch knob, it's got a little marimba attached to it, so it's, and that's probably what you're talking about. Anyway, back to work. Not that this isn't also work in its way, but the interesting thing about the EMU that I'll be looking into is whether some of the artifacts that are part of it are desirable to have. And that is a question that I don't know the answer to. But I do know that that is a thing, that you can definitely find usefulness in that. Don't mind me studying these, figuring out which one I need. Actually, I already know what some of this means, so let's go from here. Take everything above N sample frames. Copy it. See, this is why I'm interested in maybe having the notch, because this is a distorted filter. Like, the distorted filter as it applies to the low pass is in a way very obvious. The noise that it makes sounds very much like, oh yeah, that's a distorted low pass. I can hear it being distorty, and I can hear where that fits into the rounding off of the filtering. We are about to find out today, in the last hour or so of my stream, what the distorted high pass sounds like and whether I need to adjust and fool with things in order to get it to work. I've asked for examples of great places where that distorted high pass was used and where it sounded amazing. I have checked, and the drum and bass folks say that the reason that particular high pass is so good is because other stuff, the high pass will sound kind of thin and weedy. It'll sound kind of weak. But if you high pass using the EMU filter with really loud samples and stuff like that, then it ends up really having an edge to it, and that makes perfect sense to me. That is what I would expect. So the question is, I know that I would want to do a distorted band pass, because that just kind of follows. It's like, oh yeah, that's obvious. Obviously I would want to do that. But what would you get if you had a notch filter and then that distorted? That might be a really weird noise, because we don't normally do that. Normally, if you have a biquad notch filter, it's just very well behaved. And I'm not really quite sure what it would sound like to distort inside that algorithm. But we'll find out. First of all, though, let us get into this. I did just copy that, didn't I? I think I did. And we're not using overall scale because we're already calculating this. That just tells us what we're doing. And we know that we're doing a high pass, so I will skip over that other part. These are the remaining things that I would include in that. This was already there in a previous version of, this was an earlier version of the program. So this is what we have here, and this is what I need to copy over to here. So let's do that. Copy, get rid of that. Now, if I copy over the rest of it, this is going to be the low pass, but if I say, go in here and do this, these are different. These are not the same thing. And you can see how different they are because this that I'm about to delete, biquad A3 is 2 here. Here it is -2. And I can take this, and we're not making any reference to biquad A. Instead, we're just hardwiring it to that. Hardwiring being my language for plugging in the variable and not having it be another variable. Plugging in the number into this place and having it be just like, we're just going to use this number. We're hardwiring it in, meaning that it's not adjustable, it's not unpluggable, it's just always going to be this number. There are no actual wires, and it is only as hard as the surface of the screen is, I suppose. But yeah, that seems like the only variation to -2. But I have to tuck that in here too. Otherwise, that would be divided by 0, because biquad 1 would be 0 if I don't change it. And having done this, this should be exactly what I have in low pass, up to and including the fact that it's 5 stages and that the dry wet is working the way that it does. And the interesting thing about this is that the algorithm, I think that I'll have to change it when I get into the notch filters. I'm not absolutely positive, but there's some places in this where this biquad filter algorithm, sometimes I leave something out, because if something like here, if the way that I'm doing it means that like biquad 4 is always going to be 1 no matter what, then I can leave out this multiply and just use like biquad 7, because I know that I'm always going to be multiplying it by a 1. But then it wouldn't be adaptable to other forms of biquad filters, so I guess we'll find out whether I guess first of all, we'll find out whether this works right off. Very first thing, oh, I remember I was also going to do this. I often like running at very high resolution on these things. That is my way of wasting cycles rather than having fancy GUIs and such, or having a really abstracted form of the program where you're calling subroutines and methods all the time, just in order to have fewer characters to type. So let's go and copy this over right now, stopping at this point and starting at this point. See, we're not even using this lows boost stuff anymore because we're doing it in other places. We're doing it in other ways. And now that we've done that, in theory, we have something that will build. And it did. And having done that, in theory, we should have a high-pass filter that also does this craziness like the low-pass one did. And so we're going to find out right now whether we were onto something or whether we got more work to do. Open up that drum file. And let's go in search of our new plugin. Right down at the bottom there is now AX Highpass. Actually, there's several of those, but this is the one we want. Is it? Yes, it is. So, we've got a gain, we've got a nuke, we've got a freak, we've got a dry wet. What do we got? Sounds like a high pass to me. I can barely hear it. I could probably do with rolling it off lower. And that is making very loud noises also, I might add. We're making very loud noises with this. Let's find out what happens when we push it. Okay, one thing that's happening is this gets louder and louder as we go. And higher in frequency as it goes. So some of the compensation that we're doing to make the low frequency one work is not helpful. Instead, it's just making everything distort horribly. You can probably see on the screen, I'm assuming that I'm showing the screen, that it's just pegging the meters super hard. Like that's 11 dp over 0. It's all very well and good that I'm probably actually distorting the stream even. So something about this is very wrong. And the lower we get in frequency, the worse it gets. So we're going to investigate what we had, which does not apply to high pass. We were doing some compensation in X low pass to make it so that as we dropped the frequency, it got more and more aggressive and distorty, and that's not helping us here. So clip factor. Clip factor is where we're multiplying everything. We're probably going to want that, but we've got it tied to the frequency in an unhelpful way. So, clip factor equals biquad A0 times biquad A0 times get param3 times 32. Param3 is nuke, although we could make it be something like param5 to have independent control of that. And let's try that. And while we're fooling with it, let us also update these other things. That way we have some reference to what these knobs do. Now, when we do biquad 0 times biquad 0, 1.0 times this, clip factor is actually getting smaller and smaller the lower frequency we get. I wouldn't expect, well, hang on. It's probably not clip factor we're concerned with here. It's probably compensation. Because compensation is square root biquad 0 times 6.4. Biquad A0 and the square root of it, it's going to fall off. Like it's going to try to be larger than the tiny number that it's normally going to be. So, like square root of 0.001 is 0.01, I think. Yeah, I think so. Yeah, that would follow. So where are we applying compensation? We've got this in here somewhere. And input sample equals out sample divided by compensation. So that's going to get aggressive real fast. So compensation, let's see what happens if we just take that away completely. Or there's a better way of doing that. It's divided by something, right? So let's make it be divided by real quickly see what it's like if that's not there. If we divide stuff by 1, it could conceivably degrade the math of it very slightly, thanks to floating point, but that is now no longer changing. Let's see what we got. So this is with compensation disabled, and we've also moved part of our clip factor down to parameter 5. So that looks like this. Nuke 1, clip factor 1, if it matches there. Frequency like this. Now that's starting to sound less like we've definitely got this. Although all the high passes are really, really high frequency, I'm not sure that's very helpful. I feel like I can also do a quick change to set this more into a usable range. Let's expand the range of this. And I am now questioning whether to POW get param kparam 2, 3 means that the small numbers go smaller, which means that frequencies move the other way. Means that if you have a position in the middle of the slider, that position in the middle of the slider is going to represent lower frequencies because smaller numbers equals lower frequencies here. And doing this, power of itself multiple times, is going to continue to make it smaller. So it's going to change the curve of the control. And I've also just changed the range of it down to a much lower frequency, because it felt like I was getting no capacity to have sub-bass in there at all, no matter how it was set. And that seems more questionable. Now that we've done that, let's see what we got. Remember, now I've done that and I've also changed clip factor and taken away compensation. And it seemed like whoa. Okay, didn't see that coming. This apparently is what we get. Wow. Let's start sneaking nuke up a little, or no, let's start sneaking clip factor up and see what we get. super weird. As we increase nuke, we get even more gnarly effects. Okay. I don't know where this is coming from. Clip filter seems to do absolutely nothing. Okay, so the next question is, how does gain affect this? Gain affects it because as gain increases, it starts going crazy. If we have a little spike here, I'm not feeling any difference off a change in clip factor, which is weird. And part of the reason is because I clearly have nuke. Frequency is capable of going so far down that it's doing something with subsonic waves happening. Or something. Yeah, well, I didn't tell it to do this, it's just doing it. Could this be part of what's going on with the emu? I really don't know. It's definitely throwing an effect on. What I am now wondering is whether I need to go into the code and find out whether I'm using a specifically low-pass oriented version of the biquad, and what I'm hearing is not actually a real biquad. Because I don't remember biquads doing nonsense like this. I feel as if something is going on here that is not as anticipated. So let's quickly, for instance, open up another one, like say X band pass. All this stuff basically just has default code in here. Like this is the same as before. Or is it? No, apparently not. Okay, let's open up wipe. I know some of these have stuff that I just copied over and didn't do anything about. So let's have a look at wipe band pass and see whether that looks more like my default assumption. Certainly has this, the same. As I'm going to want to compare these biquad filters and see whether they're different. No, that's further on. Let's keep trying to find one. Let's try to find one so hard that I lose my words and don't know what I'm saying anymore. How about Z band pass? How's that grab you? Does that have my unedited code? One of these did, but it... No, I seem to have copied a lot of stuff into all of the versions. That's tiresome. Well, heck with that then. Let's go into the plugins folder, which is under Airwindows now. And find one of my most basic biquad implementations, which will have all of the variations here. I guess that, see, this is what I was telling you about, how this 3 parameter, the biquad kernel gets to not have one of those multiplies if you're doing a bandpass. Unfortunately, that means that the, why such old Mac OS? Because I develop on it. All the plugins that I make up to the present day are capable of running on all of the retro Macintoshes all the way back to PowerPC machines, like G3s and G4s. And then I go through the whole process over again to recompile them for Apple Silicon and the modern signed stuff. So there you go. But yeah, so this is what we've got here. We apparently have peak and low shelf as well, but I prefer not to use them this way. It's just more complicated, that's all. And there is our form. Let's just copy this out. And strangely, biquad was implemented by including it inside a stage of console, so go figure. Don't really do it quite that way anymore. So let's analyze the difference between these things. Boop. First thing I'm going to do is copy this and replace these so they look more similar. Honestly, I think this is a different form. I'm not entirely sure, but I feel like this is a slightly different form. In particular, what am I doing with like 10 and 9 here? That feels weird. Some of this seems right, and some of this isn't making any sense. Why do I even have biquad C10 equals biquad C9? What am I doing with it? It's not showing up here. I think it's a alternate form. Let's dig into another one. Let's dig into the triple biquad and see whether that's got anything else going on in it. Same calculations. Same as the original biquad. So what I've got here is coming from somewhere else. Let's see whether I'm basing all of this off of the second direct form. Because what I seem to remember is these were all a ordinary form. This was the alternate form, which was said to be better for manipulating the controls. Let's see what we got. Sure enough, that's where biquad 10 comes from. It comes from this other form, which is said to be DF1, direct form 1. Okay, so that's where that's coming from. So apparently this is, this is the same formulation that was in the, I think what's happening is we are now hearing what the inverse of X low pass was really like. What we're hearing, and this bizarre effect, is essentially what's being taken out of X low pass. And when it's done as X high pass, it's doing something else. Now my question becomes, well, first of all, is this useful in any sense? Second of all, is this just a matter of the clipping? And I can find that out fairly quickly by, we were getting that even with nothing happening. So when I say nothing happening, I mean when I had nuke at 0, none of this was running, only one level was running, and it was still getting it. So if I do this, we're no longer distorting. Let's see if it's still doing that if we're not distorting. Because we might be on to something as far as what we can and can't do with the distorting in the high pass. And it would explain a lot about why the sampler high pass has extra edge to it. Because this is where the old right brain really kicks in. Firstly, let's test the theory. We now don't have distortion on the first part of this. This is no distortion. And we're rolling off as low as we could possibly want. And it's acting totally normal. Then if we include nuke, nuke will bring in one of the filters that does have distortion inside it. So this is what we get. When we distort inside the high pass, it makes a swoopy noise up. We're getting a note out of it. We're getting an artifact out of it. So why is it making a note? Why is it making a swoop? Because we're using a sine for distortion. When we are distorting, using the thing that we're using for low pass, X low pass, we're using a sine wave and we're clipping it to the maximum distort point. But a sine wave is always affecting the frequency when it is being applied. So there is no point when the distortion is being applied that it's not modulating it in some way. So for that reason, there's a difference between what I'm doing there and what's happening in the EMU, because the EMU is also distorting the inside of the filter, but it has a hard clip. A hard clip would not be making the frequency go swoop. A hard clip would be making the frequency do an abrupt shift to a different frequency, which would cause certain artifacts that we can hear. And I'll show you how. Mind you, that's kind of loud, so we'll store that there. Tell you what, let's just hard clip it to a really small level. There, now we have a hard clip, and we're not doing a sine factor, so we're doing this distorting into Highpass in such a way that it's an abrupt change from one state to the other. When we did it with a sine distort, it would go swoop. It would make that freaky noise, which is arguably not desirable. I mean, it could be desirable, but it's certainly very loud relative to the rest of the sound. And it's basically space drums right there, so it's I'm real interested in what we get here. That'll be something different, because we're now distorting at a much lower frequency than the EMU ever does. Zero gain. Okay, interesting. If we clip hard enough, we make that swoop anyway, even though it is only a let's clip even harder. Okay. This is pretty weird. So the interesting thing will be finding out whether you can make the EMU do this. I don't know. It's definitely a factor of how distorted you have it, and I don't think this is going to stack up nearly as well as the low pass does, but it's definitely a sound. So then also the question is, well, here's one question. Seeing as we made it do something else, let's change it for all of the levels and also change the sign away so that it's not sine for all of the levels. And that's done like this. Now we are making no attempt to do a sine-based distortion, and we only have the hard clip, which is consistent with what the EMU does, except for I don't know that this is how that works. But fairly easy to change everything. We'll keep that there though, just in case we want it. And now we have multiple levels that are all clipping at about 0.5. We could be using clip factor for this too. There's a variety of things that we can do. For instance, use it as part of nuke, as nuke will continue to drop that down into sort of the audio path there. I'm also real curious to know whether at multiple levels, if we have multiple poles of the filter, is it going to make a more interesting noise? And of course, as near as I can tell, this will go completely bonkers in a steady state sound, but maybe that's not what people use this stuff for. Maybe it's being used largely to cut transients off of loud percussive noises, in which case this does do something different. And that's why we call this the X Highpass, is because this is experimental. We'll see what happens. On to the drums. I am at least relieved that it's not blowing up the volume levels anymore, although it's making oppressively loud noises regardless. But that's kind of what people wanted from it. We're definitely hearing, in fact, I got to turn that down. I will hurt my speakers that way if I ain't careful. This is just silly. See, here's the thing is, I'm pretty sure that the EMU didn't go down to the subsonic frequencies I've set it to anyhow. So it's a bit of a moot point that I can make it do this. The EMU would be more like up here and less phases of it. So 0 or 1. Let's give it like 3. Yeah, no doubt. And it would also be very hard to drive it this hard. So the question becomes, can you take the EMU and throw enough internal gain that you can go into the high pass and make it do these zaps? And maybe if that is what people want, I mean, I don't know. That's why I'm asking. That's why I'm trying to ask people, like, how are you using this? Show me examples of what it does. Because if you can do this with it, some drum and bass guy is going to have done it and put it into a track. And then, oh man, the snare on that track is amazing. Yeah, it's because they distorted it using this. And their snare basically does this. And people were like, wow, what an amazing sound. Because they do say, oh my god, it's so aggressive, this high pass in the EMU. It's so aggressive, and that would be true if this is what it's doing. But I gotta wonder. I'm also wondering whether we hear any of that under normal circumstances. Like, there's our low pass again. A bit of nuke there. Another thought is maybe if you have multiple poles of this, you use the initial pole to create that noise and cut stuff off, and then subsequent sounds just high pass the result of that. It's certainly making percussive noises. There's a real super extreme nastiness on it. Let's find out. I don't think I have any big swelly pads, but I can play something that's more sustained, like Alien Kittens. This is going to be ugly. Oh my god, this is going to be a nightmare. Let's find out together. Yeah, if you clip it, you get something nasty. Time for some more experimenting. There is definitely some stuff I could try to do here. And one of them is, let's start using Nuke for this clip factor. And another one is, let's get rid of compensation. There's essentially no benefit to that. So we're going to stick with this. We're going to stick with the hard clip because using sine just guarantees that it's going to be nothing but a space odyssey. And I did a plugin called that years ago. Don't mind me, I'll be finished with this in a moment. That's just a successive assign, so we're not even bothering with that. Just like, okay, all of you, we get to be equal to the same thing. Just straight across like that. Boop. And for fun, we'll do one more for just this one alone, because we can. So that's simple. Now, what is up with this clip factor? This is how we get to have increasing gain. But successive gain isn't necessarily going to help us here. Like we're not necessarily stacking it. Or are we? That's a very good question. So clip factor, outsample times equals, so we're increasing. It's getting progressively smaller as we do this, so we can make it amp up a little bit there. I want to say value, threshold, more accurate. We seem to have taken out, oh no we haven't. Let's stick this back onto nuke again. 3 is our nuke parameter, and we're going to use that again. Now if we just only did that, we would go down to 0 and clip threshold would become 0. We could see what it's like. Seeing as the increasing steepness of the filter doesn't necessarily help very much, maybe we should see what it's like. Or maybe we should be clipping progressively as we go through more stages of filtering. One thing about it is that the more high passing we do, the less high output we get, and the less likely we are to clip as we go forwards. So increasing clip factor we could increase clip factor a lot. Like make it so that it would crank out lots and lots with every step. But for now, and since we're not including the minus, that part will still work. Now we have it adjustable. And we're no longer saving this because we don't care. We're not using that sign calculation again. This is a hard clip one. And sure enough, I'm comfortable enough with the idea that we're on the right track that I will just delete that. You can find it in an older version of the plugin or in Xlowpass if I really wanted to. Onwards into the ugly noises. Let's see what we get out of Alien Kittens before we throw in the drums again. This is going to be messy. Alrighty, that's interesting. I got a lot of gain on it. Okay, this is doing something wrong. Yeah, if I have this set wrong, it pops and goes crazy. Okay, that's rough. Too much gain somewhere. Too much gain somewhere. Alrighty, so clip factor, how about we take that way down? going to become a much smaller number because we have such intense boosts in there, and that's one of the things that's causing it, and that's one of the things that would make that be happening. Back into the breach with less gain on that. What do we got? No different? Huh. That should have made it be less. That stuff should still be okay. Outsample times clip factor, that's always helpful. Well, if we take that out completely and do everything with input gain, factor of 8, lots of gain on tap now. What do we got? Clip factor now no longer boosts from stage to stage, but we can slam the input insanely hard if we want. Are we still going to get the same mess, or is it going to be a different mess? Interesting. We're starting to see something that I might almost call a result. The harder you clip this, the crazier it goes. Our control range is still very difficult. Like, this is so freaking bright. It needs to be, this control would go over here. Yeah, we drop into the range where we're now filtering the bass. It gets real gnarly. Unity gain. At unity gain, it is behaving itself, kinda, or not. Interesting. Yeah, I can drop it down enough to freak it out. This is never going to be a bass high pass. Not in a million years. Well, let's see what happens when we're not distorting it. Let's turn it back down again. Uh-huh. All right. So this is our sustaining noises again. I think we're zeroing in on what's going to be a good X high pass, but the experimental factor is very clearly woof. I can see how this would be useful to people, though. Yeah, differences between not just another dither is you should be using monitoring for it. Monitoring should be the same one as in Studio 10. Ditherbox is a slightly earlier one, and I don't remember what the redux would be. And I wouldn't be using naturalize, although you could. All that's going to happen is it's going to handle things at the noise floor a little bit differently. So I would say, I don't know, see whether one of them sounds better than another and go with that. It's slight tweaks in the way that it handles things. That's basically it. So, while we're at it. I think this is a good example of what somebody might consider to be a high pass that sounded really aggressive rather than just thin. It's doing it through going insane, but there is no question that it's aggressive. I mean, probably. You could look at the code if you really wanted to find out. Well, this is purely the torture test, so we've made a couple of changes. Let's bounce back to that drum track and see what that sounds like too. Yeah, basically how this is working is, especially as we include a little bit more of it, I'll tell you, remember how we had a thing in there called clip threshold? Every step of the way, we're now adapting this to what's called clip threshold. And if it's larger or less than the clip threshold, then we're sticking it to that. Clip threshold is now tied to nuke. So what we're getting, and I think this does work, is it goes up, the clip happens more, and if you crank it all the way up, you're clipping everything to literally 0. Complete dead silence, while simultaneously running through maximum stages of the filter. So this is purely like Laser Town. Maximum lasers at maximum nuke. At maximum gain. And it's all kind of associated with, firstly, what frequency you want and how hard you're pushing it. But it is compelling everything to go a lot quieter when we have it completely bonkers. We're just cutting it down to next to nothing. Remember, we also adjusted gain. So gain is now like this number plus 0.5. So it's going from minus 0.5 to 1.5, multiplied by itself 8 times instead of 4. So this has an enormous amount of gain or gain attenuation on tap. Like here's the maximum amount of cut we have now. You can barely get anything off of it at all. It's like 50 dB down, meaning that the opposite is going to be like 50 dB up. All that happens if clipping is maxed out below silence is more silence. Like the way that that works is if outsample, actually that's not quite true, but close. If outsample is larger than like -1, outsample is equals -1. And then if outsample is less than -1 or 1, which it would be, outsample equals 1. So if you have clipping maxed out below silence, it will only produce DC offset at the level of whatever clip threshold is beyond 0. 0 is the smallest number you should have for that. Let's fool with some of these things a little bit more, although it's getting on towards end of the stream time. But I'll put this back for now. I'm going to put this back because my low range is not actually useful here. I'm going to keep it to what it was before. And let's increase this and see if I get any better range. That should all be fine. All of that is nominal. Clip factor. I do remember one of the things that I did. Oh yeah, we removed clip factor completely. Well, now that I've got it doing something, and we've more or less become comfortable with the fact that it is still an enormous mess, any clip factor is going to make stuff more extreme. Biquad A times biquad A times get param 3 means that the amount we add is tinier and tinier at low frequencies and larger at high frequencies. Get param 3 is, of course, nuke. And times 4 is way more than we need. So the largest biquad A0 can be a 0.5. It's going to be less than that. 1.0 times 0.5 times 2 would be 2. Oh, we can see what we get out of just this, out of just that times nuke. That means that at high nuke levels, we're going to get an increasing amount of boost the more high frequency we got. This being the frequency control, or what belongs to the frequency control. At low frequencies, we're not boosting nearly as much, which is probably just as well because it makes horrible effects when we do. Let's see what we got. Huh, okay. That's weird. Wasn't expecting this. It's weird though. This is definitely from incorporating more levels of this clipping. This no longer bears any resemblance to a high pass, so clip factor is not proving terribly useful. Clip factor is about boosting every step of the way. It seems like we're not going to want to do that, because every time we hit clipping, it freaks out. And if we hit clipping and it freaks out, and then we boost again and hit clipping again and it freaks out more, it just replaces the sound with a hideous, gnarly mess. So let's go after all these clip factors. Clip threshold is more useful. Just kind of making a command decision there to take that out completely, make it go away. And now let's see what we got. I'll throw some other stuff on if this even remotely works, and we'll see what we got. Oh. I feel kind of skeptical as to whether this is really taking me a useful place. Yeah, I feel like this can't possibly be right. There is no chance that EMU does this. I guess I'll just have to try and find out. I'll test it. And also, hopefully the folks in the drum and bass forum will respond when I ask them, like, well, what does it sound like when you're using this to full effect? Because right now what we got is a bit of a mess. Well, the one thing about it is when it does do this, we're getting a really nasty, aggressive punch on things. Not only that, the way that the nuke interacts with turning it up is kind of effective in its peculiar way. Like we have some of that nasty punch, and we can punch it even harder, and it gets increasingly gnarly and strange as it goes. I feel like the big drawback here is you drop freak and it doesn't change. Maybe if I made nuke also a factor of freak, like whatever nuke is set to is times freak. So at highest frequency you get the fullest effect. 0, nuke is unable to clip and distort anymore. Let's quickly throw that in. So 1.0 minus times, and let's see, gain, so it's going to be parameter 2 I want. Therefore, full clip threshold only when both of those are maxed out. And if you drop freak, you're also cutting back the clip threshold, which might or might not be significant. I'm also wondering whether maybe having multiple levels of this is but that would be another question. wondering about leaving off this one entirely, or let's quickly get rid of that one clip right there and see whether we can get it into a zone where I can take this and go from crazy, gritty, high passiness, drop the high passiness and have it go clean. I don't know if that's possible the way things are set up. Got a lot of gain going into this too. Yeah, let's cut some of that gain. Unity gain. Now what do we got? We've got a high pass, and it cleans up. We've got a high pass that's maybe a little dirtier. Huh. Crunchy. Unity gain again. Getting some of those nasty artifacts, gotta say. Should be able to get more gnarliness even in the middle of the control. Let's double it. Let's just double it. So clip threshold, let's get param 3 times get param 2 times 2, and then we're going to clamp it. And we might want just a hair of it in there, but or maybe not. Or 1.0 times get param 3 times get param 2. So param 2 is frequency, so it's getting smaller as we go. Here's a weird thought. through. We don't need this any longer, so now what do we got? Bear in mind, I'll accept it not going super ultra full tilt bonkers and replacing the entire sound with zaps and snorks, because I'm kind of trying to get something that has functionality and can be used in the aggressive way people want to use it without literally just replacing the entire sound with madness the whole time. So that's pretty clean. Here's our lows. I think we might be getting there. It's still kind of cleaning up, but we can go real aggressive with it. And this is at unity gain, no gain trim. Yeah, like relatively clean. Increasingly nasty. And then real glitchy. I don't like the way that the high frequencies are over here. Like this is just silence. That doesn't feel useful. And of course, since we do have the gain control, we can make it go crazy. Huh. Okay, well, there's a thing. I'm trying to think of whether anything else comes to mind at the moment. Like I was talking about a variety of stuff, really. I don't think I can get that squelch to be any better behaved by using different distortion forms, and I know that the hard clip is part of the EMU version of it, so it might be on the right track for that. Let's throw some other noises at it just before we go. Okay, that's super nasty for what that's worth. A lot of gain on this. Let's put this clip stage back because the output was so loud. Because this doesn't have to be good or correct, and the designers of emulations of lovely analog devices would think that I was completely bonkers, but I don't have to care if I can make something that drum and bass people would be super into. Okay, that's mean sounding. Still have an awful lot of gain going into this though. definitely able to reshape basses too. Like, this is what this really sounds like. Then you kick in X Highpass with a lot of gain in it. We can swing this stuff around. This is what it's supposed to be. The way that the kick comes through it. And if I have it set to this, pretty much nothing's clipping until you sneak this up. You start getting these weird crackles. Yeah, I'm gonna go soon myself, though. It doesn't handle widely varying volume levels either, but this has Nuke doing useful things, whatever the frequency range is. Like here we have a distortion on the hats. And it kind of cleans up, and then gets even more aggressive. Oh, wrong dry wet. And then we can even blend them. This compared with this. Alrighty. Well, that's a half an hour later. That's a half an hour later than I intended to go, but I feel like I got to a result finally. Neat. Okay. So the reason I'm pleased with that is largely because I've got it so that you can slide the Nuke around and it does useful things regardless of what it's set at. So I dare say we can call that the experimental high pass, and I can probably give folks that next Sunday. In any case, I'm going to call that a day. I ran later than I expected, but that's all good. Anyways, talk to y'all later. Man, biquad filters are loaded with phase shifts. I'm not even sure what you're talking about there. It's going to have all the weird shifts and stuff imaginable. That's a super messed up thing, so go figure. Anywho, talk to you folks later. Bye-bye.